Yeah, I was saying like I've lost something to share, but let me first present my latest cool projects that use Wan2.7 to turn Markdown into cartoon videos. So I'm Zach. I'm also a YouTuber on the side. So one of my pipe dream as a YouTuber is that I want to generate a lot of educational content, but I also want to animate this content. So for instance, if given a neural network Markdown file and teaching people about how neural network works. Ideally, I want some cool cartoon character that have conversations that inspires the stories that teaches people neural network actually works. So how did I achieve that? I use the latest Wan2.7 models, which are pretty cool. So the first model is the image model, which as Ryan has already shared, given test, you can have some a given image, you have some text like cat to dog, and it will changes the character. It will directly change these characters. The other is the video model. So you can also animate these images. So here, given the cat models, I can let the cat walk around. You can also see a little bit of the sound of the ocean in the background. But two models are like the workers, but we also want to have like a workflow that chains these works together in order to produce something more production ready. So I was actually the creator of Pocket Flow. And at a high level, it's a large language model framework that I personally find very useful because when I was building myself and open source that, and it gets a lot of tractions over 10K stars for now. So I, based on the models and the framework, I built this pipeline that given a markdown, it will plan the scenes, write models to generate images, then you generate voices, animate the images, and finally stitch them together to generate the final educational content. So the first step is actually plan the scenes here. The problem here is like Markdown is pretty boring. It teaches you about how neural networks works, but no one actually want to read that. So what I did is actually ask the large language model to plan a few cartoon scenes between two characters. I designed character Mia and Ding Ding Dog. One is a confused student and this is a teacher, and they alternate across the scenes. So Mia starts frustrated with the homework. Ding Ding Dog shows the brain hologram, and Mia asks, how does the dog learn? The dog shows the weight dial. Mia then asks, what if it's wrong? The dog explains what backpropagation actually means, and finally, they celebrate. So given all the things which are a bit high level, we need to really flesh out the details on how the image, the narration, the animation work here. So it's also a large language model prompt. It's also prompting the large language model, given the scene description, generating the dialogue, generating the image styles, and describe how to animate that. So for instance, for the scene that Mia is sitting at her desk, looking frustrated, surrounded by homework about neural networks, the dialogue will be, oh, my brain hurts. How am I supposed to understand this neural network? And then we prompt it to have an anime style image with the instead of bedroom, yes, at the desk, dogs look up sympathetically. And then the image will be animated in a way that is slow motion, a slow zoom in on desk. Mia drops head, papers flutter, dog waddling, bells jingling. Then we need to generate images based on for each of the scenes here. So here are some example images generated from the Wan2.7 models, which looks which looks pretty cool. But one thing I want to highlight is that this didn't happen by default because one of the biggest issues when you use image model is the consistency problem here. If you just describe help me generate a blue dog with yellow bill on a red ribbon and a girl on with a round glasses, you will kind of get all different styles of the characters. And if you change them together, the whole video will just look very, very weird. So how do we have consistency across the scenes? Actually, a bit challenging, but the idea here is actually just use references because now the Wan models takes all the reference images. You can just give them your designed characters. And actually, the character design is also generated by Wan2.7. I've tried to prompt the Wan models and tune the prompt a bit for different reference sheet some of the reference sheet looks a bit creepy, some looks too cartoon-like, and I choose someone in the middle, and the final reference sheet look like the one in the below. Then given the reference images, there are also layers of consistency. So for instance, for the text images, I also keep prompting model what the character looks like in text details. Also, it's not only about character, it's also about the scene. You don't want, the previous scene is still in the bedroom, but next scene is in the classroom. So you also need to provide all the previous output of scenes to the models. So when it change the scenes, it also have this environment level consistency here. So given that we have the image ready for each of the scenes, then we generate the voices. I use the cursive voice. So Mia is a kid who sound like this.
Ding dong. What even is a neural network? The teacher explained it for like an hour, but I still don't get it at all.
And Ding Ding Dog sounds like a teacher on tenure.
Don't worry, Xiaomei. This way, your brain has billions of tiny cells called neurons, right? A neural network is basically the same idea, but on a computer...
Ding dong.
Oops.
What even...
Sorry, okay. So finally, given that we have all the scene description, the image, the ready, we want to animate that. We don't want it to be just like a comic book. We want it to be actually a video. So we use the latest Wan2.7 video models to and given the prompt we generated before to animate all the scenes images together. So given the image to the left, if we prompt it to be Maya jumps out of the chair, papers flies, Ding Dog hops in celebration, this will be the results. Okay, so we have all the 7 scenes, all the animated clips and all the audios together. Then we use the FFmpeg to stitch them together. And this part is actually a bit technical details that probably I will just skip here. But without first ado, I really want to show you the final result.
My brain hurts. How am I supposed to understand these neural networks for my computer science homework? It just looks like a bunch of confusing dots and lines.
Shh. Don't let the dots and lines trick you, Mia. Neural networks are actually inspired by the human brain, using interconnected nodes to process information, just like you do.
Okay, I get the brain part, but how do a bunch of glowing dots actually learn to recognize patterns from the data? It still looks like magic.
Shh. It's not magic, it's math. See these dials on the lines? They represent weights that automatically turn and adjust during training to help the network figure out exactly which paths are most important.
I'm still confused. If the network makes a mistake, how does it actually know which way to turn those dials to fix it?
Shh. It uses a trick called backpropagation.
Wow, it actually works!
Like a little helper walking backward through the network, checking mistakes step by step to tell the dials exactly how to fix the errors.
I get it now. So by repeating that backward step over and over, the network learns from its mistakes and finally makes accurate predictions. Thanks, Ding Ding Dog.
Okay, so that's it. Thank you so much. I want to, so we're using the Wan2.7 models and cursive voice. You can also find me on different social media, including YouTube, GitHub, and X. That's it. Thank you.